this is a nice question here. I believe, if I remember from the eons ago, this is a geometry question, I think.
That is.
Okay, good, good. And it says, what is the volume of this block? And let's see. The base, or one line, is 9 inches. And then the bottom looks to be 10 inches. And then it looks to be 3 inches high. So
Yeah, I can
calculate the volume of this.
take that one. I'm just trying to sketch this really quick because I didn't get a chance to copy it yet. Let's see. Let's see how this box looks.
You're the
All
best
right,
drawer on the
there we
show,
go.
that is for sure.
I try. So this box is 9 by 10 by 3. And I don't want to go too much into how this formula is derived, but when we talked about this before, or just in general about volume, kind of said that volume equals area of the base times the height. And I don't think there were dimensions on this, but I think it's important to talk about that. So I'm going to call this a box, 3 inches by 10 inches by 9 inches. So you could write different volume formulas for all these different shapes, or you can come up with one generic one that works based on any shape that has this kind of prism. When I say prism, I say that, think about like this kind of box, like this face right here. If you can imagine the face in the back, can't really see it, it would look exactly the same. So it's actually maintaining the exact same shape throughout. So when we do this, we're saying that this capital B here is the area of the base. So really, whenever you think about the shape of the base, I think it'd be a little confusing sometimes. Not so much with a figure like this, because you could do it a couple different ways and be okay. But with other figures like trapezoidal prisms, where you generally think of a base as something that's like sitting on or supporting. So like if I looked at this calculator and I set it down, I would think of the base as this object. And it gets really tricky whenever you have triangular prisms and things like that, because a lot of times my students see that and think, oh, whatever's on the bottom is the base. But keep in mind, these are three-dimensional objects, and we don't live in like a totally flat space. This can be oriented a lot of ways. Like I could orient it this way, and now I've got a base that's a different shape. Or I could orient it this way, I have a base that's different shape. So what you typically want to do with these figures is think about like what is that main shape that gives this three-dimensional object its figure, in a sense. In this case, I'm going to say my first thought is it's really this rectangle. So the area of the base, well, I can rewrite this equation as the area of the base is length times width of a rectangle. And I'm going to kind of rush through this a little bit because we're running out of time. But I'm going to rewrite this then as volume equals length times width times height. And then all you're doing is kind of plugging in some values here. We're going to say volume equals, if I look at this rectangle, I have a length of 9. And it has a width of 3 because this is 3, or this is 3 here, so this has to be 3. And then again, kind of the orientation, the height is 10. Keeping in mind, you could turn this and it would be more of what you're used to seeing. So volume equals 270. And we use this inches cubed. And really quickly, the reason why we do that, and an easy way to remember this is because when we're multiplying the units as well. So if I throw little inches, 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 9 inches times 3 inches times 10 inches, also multiplying the unit, we get 270 inches cubed. So hopefully that helps.